So hi everyone. I was not supposed to present today, but so first to begin with, I would like to thank PGS for not being here. And then I will take this opportunity to speak to you about the Greensand project offshore Denmark, where we've been talking about pioneering in the CCS industry. And I think this is a great subject to talk about how we can pioneer with the Greensand project and with the pilot injections they've done last year. And we took the opportunity to monitor the pilot injection with a new seismic surveillance technology that I will present to you in this talk. So to begin with, talking about CO2 storage, we need, and we had a full presentation on that, we need to talk about safety and security. But now, the main challenge for monitoring, reporting, and verification is actually the social impact of the technologies that we will use, the environmental footprint that will go with it, and of course, the cost. Because we are here talking about waste management, we are not talking about oil and gas production. The economics is way different, and technologies that have been developed for oil and gas might not be as applicable to CCS, well as it should be. And eventually, when we talk about the frequency of monitoring, 4D seismic will not meet the right challenge to be frequent enough in terms of monitoring. But seismic is still a great tool to monitor CO2 and to monitor saturation and pressure front. And here I will begin with the obvious. This is a slide that might not please geophysicists because I'm a geophysicist and I'm not building images of the subsurface. Well, I'm using only one seismic source and one seismic receiver to monitor a specific location in the subsurface. And I will tell you first why we can do that, and then how this is possible, taking the Greensand project as example. So, yes, I will go fast on that because I have time to keep. So first, what for? We are talking about safety, so I will take an example. When you want to prevent fire in your house, you have several options. You could do a full thermal kind of image of your house, or you could use a smoke detector. One of these technology is commonly used in your flat and houses. Now, when you're using smoke detectors, you will not put them everywhere. Well, except in the US, they like to put it in every room. But in Europe, actually, we have some smoke detector to locate in your apartment. And most of the time, you will locate them in specific location. First in the kitchen, because we know the fire might likely start in the kitchen. And then you have to place one in the entrance because if you have smoke in the entrance, you need to know it before it's too late and you need to get out of the apartment or the flat. Now, what I want to tell you in this presentation is that, yes, you don't need right away, well, a new image and a full image to ensure safety and security in your CO2 storage. And I want to show you a pragmatic way of monitoring your saturation plume and your pressure front with seismic. And when you don't have a seismic image, you have something that looks like an image. This is your reservoir model. And this reservoir model is actually key in a TCS project because it's the center of the whole project. It will trigger the investment decision. It will trigger the risk identification. It will trigger the payment application as well. And you will have CO2 credits based on this reservoir model. So it is paramount to monitor that this reservoir model is actually accurate and that you can make it safer and safer and sure by reducing its uncertainties. So to do that, you could have technologies to monitor in specific location if your reservoir model is wrong, and if it's not, you can adapt it over time and make it more and more trustful. Now, the $1 million question, how often should you monitor on your field? On many CCS projects, we hear the common, we'll do a full image every 4 years or every 5 years. But what will happen between these 4 years or 5 years? Will you be blind? What will you monitor in this storage? So we need to have frequent monitoring technologies, and it's not only seismic, it's passive seismic, it's DAS, it's a receiver, it's gauges, it's a lot of stuff so that we can ensure the storage safety. Here, I want to show you why the reservoir model is important and how we can use it to trigger the right technology at the right time and at the right location. This is a saturation map on the Greensand project. You can see this is month 8. You see month 9, month 8, month 9. What we want to see here is the new cell that will be affected by the CO2 saturation in the prediction. And here we are not only interested in the new cell, but we are actually interested. So if I do that, will it work? Yes, it's working. So if I do that, so you can see a month by month saturation map with some hot location at each new cell of saturation that will happen over the storage life. And you can see here on the right side of the slide that I have the highest saturation point at each month. So I'm not telling you that you should monitor each month, but I'm telling you that there is one particular month that is critical to monitor, and it is month number 5. So if I show you month number 5, you can see that this is a month where the saturation fronts become, is acting differently in the reservoir. You start to have a southwest kind of direction. And this is a specific moment where you need to validate that your model is going in the right direction. So you need to have a seismic measurement that will focus the measurement on this position so that you can increase the confidence in the reservoir modeling. Yeah. And of course, this was for the components, and you have the same kind of thinking for the containment, where you can have an abandoned well, just locate some spot between the saturation front and the abandoned well. You have some fault, you have an uncertainty about the potential leakage, just have a spot on each side of the fault, and so on. When you have spot seismic, you can use as many spots as you want on the field to increase the confidence on your field. Now, what happens if the detection is not matching the model prediction? Well, just like the smoke detector, most of the time you don't have a fire in your house. I truly believe that CCS storage is something that is quite safe. And most of the time, your models are right because we can choose where we want to eject. We can choose the storage location where we have the less risk, and so on. So here we have less risk that in any kind of oil and gas project. So most of the time, you do nothing, you don't have a leakage, and everything is according to plan. Sometimes the, the toaster might be smoky. So you need to have, in this case, most of the time you need to have a model update. And that's what we've done on the Greensand project. We detected CO2 on a location that was not expected to see CO2. And by doing a reprocessing of their 3D seismic, they could explain why we saw CO2 at this location. Well, and then sometime it's really not a match with the reservoir prediction. So you need to trigger more invasive solution, 2D line, walk away VSP. You need to have more information and more data on your field. And if the full kitchen is on fire, then you need to call the firefighters. And you know you need a 4D seismic. Well, and maybe you will need a 4D seismic 2 years after injection, 4 years after injection, or even later, but at least you know you need it and justify the use of 4D seismic. Now, quickly, how this is possible to use only one seismic source and one seismic receiver. Well, first, we need, of course, a reservoir model to know where to focus the seismic measurement, and we need also to have a 3D seismic on the field. That's a good thing on CCS project to be able to do the feasibility and so on. We have a 3D seismic. So we need to use that to know where we will locate the source and the receiver. Because thanks to that, we will perform ray tracing algorithm in the 3D seismic to go back to all of the source and receiver that saw each spot in depth. And we will be able to go back to the raw seismic traces and to select the best potential source and receiver combination to detect the CO2 effect at the storage level. So here we begin an optimum selection. Now, which traces is the best to use in terms of signal to noise ratio and detectability for the CO2. Now, let's see quickly on the Greensand project. This was a sketch that we showed 3 years ago, and we've done it last year. The idea is to use a supply vessel, not a seismic vessel. This is a supply vessel that was already on the field, that was already paid, and we've used it 3 times in winter in the North Sea for 48 hours each time to perform seismic acquisition. So first, we drop each node at each receiver location for each spot. We can just drop them from the boat. Then the boat will go with a small seismic air gun to vibrate for 1 hour at each source location. We will repeat 50 times the shot at each source location to increase further the signal to noise ratio thanks to temporal stack. Then we will recover the node by acoustic release, and we go back to the harbor. Here, main advantage, supply vessel, a very small setup, air gun of 200 cubic inch, making a point source of 600 cubic inch. And then we had dynamic positioning to stay at the same location between each shot and each monitor. And at this acquisition, we were able to have 50 centimeter accuracy at each source location between each shot and between each monitor. So I will go quickly on this. Okay, we had a great repeatability thanks to that. And then to finish with, we had an environmental footprint that has nothing to do with conventional imaging seismic. And that was really helpful to navigate in the North Sea and for the fisherman activity, maritime traffic, and so on. We had to trigger on the right weather window to go between 2 storms because in the North Sea you have a lot of storm every time. But when you have an acquisition of 48 hours, you can just pinpoint the right window to perform an acquisition. And that was the result. So final slide. We had a match with the model on every spot location. We had multiple antennas detecting each of the spot locations that you can see here. And we had a detection that was not expected on spot number 3, well, as I was telling you, but was totally explainable thanks to a model update. So thank you for listening.